Hello friends, this is Priyanka. Today we are going to solve a problem on Nyquist plot. In this video we are going to draw the Nyquist contour as well as we are going to determine the stability of the system. So let us first understand what is the given open loop transfer function. G of s, h of s is equal to phi divided by s, s plus 1, s plus 2. Now we have to first determine how many number of poles and zeros for this given transfer function. So s term is in the denominator, so we will equate this denominator is equal to 0 and we will get the number of poles. So when we equate this to is equal to 0, then we will get s is equal to 0, then s plus 1 is equal to 0, that is s is equal to minus 1 and s is equal to minus 2. That means there are three number of poles. One pole lies at origin and the other poles lie at minus 1 and minus 2. Now from this we can conclude that whenever there is the pole at origin, then there are total number of sections for the Nyquist plot is equal to 4. Because here S lies at or pole lies at origin. When this does not exist, that is when pole is not at the origin, then there are only 3 sections. So what is that fourth section? We will understand with the help of this diagram. For that we have to first draw here one horizontal line, that is the real axis, symbol is sigma. One vertical line, that is the imaginary axis, and here symbol is j omega. Now for the Nyquist plot we have to show the different sections. For this given system we have to show 4 sections because S is at origin, or we can say pole is at origin. Now we will understand one by one section. So I will first highlight the first section, that is C1, with this help of green marker. Now how we can define this section C1? So section C1 is along this imaginary axis j omega. Here is origin, that is 0. Now above this origin we know that here is plus sign, that is plus j omega. All these signs above this 0 is having plus sign. So we have to put here s is equal to plus j omega for this section C1. So whenever we put here s is equal to j omega, then this plot is known as polar plot. Now we also know here start point is at this 0 and end is towards the infinity. Now here what is this infinity? That is plus infinity, because along this half line there is the plus sign. So we can say that omega varies from 0 to plus infinity. So whenever we have to define the section C1, then we have to draw here the polar plot and omega will vary from 0 to plus infinity. Now we will move for the next section. So next section I will highlight. So this section we will say C2. Now how we will determine this section? So if I draw here one line passing from origin, then this section we will determine with capital R e raised to j theta, where R tends to infinity. Now what this e raised to j theta, that is for the phase angle. So here theta will vary from plus pi by 2 to minus pi by 2. Now if we observe this section C2 is start from this point. Now at this point angle is plus pi by 2. So if we plot the angle, here is 0, then here is 90 degree. So 90 degree means what? Plus pi by 2. If we plot angle in reverse direction, then here is 0 and here the angle is minus pi by 2. So we can say that r tends to infinity and theta will vary from plus pi by 2 to minus pi by 2. So I will write here theta will vary from plus pi by 2 to minus pi by 2. Now we will move for the third section. So the third section I will highlight here. I will show arrow also. Now how we will define this? Now this section C3 is along this imaginary axis but below the origin. So here all the signs for this imaginary line are negative. So here is 0, then we will say that here is minus infinity. So we have to put S is equal to minus j omega. And whenever this S is equal to minus j omega, then plot is known as inverse polar plot. And omega will vary from, now if we observe this direction, then direction is from minus infinity to 0. So we will say that omega will vary from minus infinity to 0. So this is about the section 3. Now we will move for the fourth section, and it is because here for this given transfer function pole is at origin. So here is the fourth section. So this is very small circle. So how we can define this fourth section? So I will write here separately. For this section 4, how we can determine this? So for this section we will determine here, or it is determined by small r e raised to j theta, where r tends to 0. And what this e raised to j theta? So e raised to j theta is for phase angle and theta varies from. Now if we observe here, theta varies from minus pi by 2 to plus pi by 2 because arrow I have shown in this upward direction. So along this imaginary axis, if we observe, theta varies from minus pi by 2 to plus pi by 2. Now we will move for the first step, that is for the mapping of section C1. So we know that the information about the section C1, that is omega varies from 0 to plus infinity, and we have to put S is equal to plus j omega. So when we put S is equal to j omega, then our transfer function g of j omega, h of j omega is equal to phi divided by j omega plus 1, j omega plus 2. Now when we put S is equal to j omega, then it is the polar plot. So for the polar plot we have to calculate magnitude as well as phase angle. So how to calculate the magnitude? So whenever there is the j omega term, then we have to take square root and square simultaneously for that term. Now we have to take the modulus. So modulus of g j omega, h j omega. Then what is the meaning for this modulus? Now we know that what is the value of j? J is equal to under root of minus 1. That means j square is equal to minus 1, and if I take the modulus of j square, then it will become plus 1. So we have to refer here j square is equal to plus 1. So I will write this phi divided by. Now here we have to take square root and square for this j omega. So square root and square at the we have to take simultaneously. So here j square omega square, but this term is in the under root. So for this j square we have to take plus 1. Then under root of omega square means what? Under root of omega square, that means omega. So I will write here directly omega. Now for the second term I will take square root and square simultaneously. So here also j square omega square plus what is the square of 1, that is 1. So for this j square it is plus 1. So simply I will write omega square plus 1. And for this third term also I will write omega square plus 4. So this is the magnitude. Now we will move for the phase angle. How to calculate the phase angle? So we have to refer these terms, S term, or we can say j omega term. So here for this j omega there is no any real part. So we know that when this term is in the denominator, we have to take minus tan inverse of imaginary part by real part. So imaginary part is here, that is j omega, but real part, that is no any real part, that is we will say 0. So omega upon 0, that is equal to infinity, and what is the value of tan inverse of infinity? That is 90 degree. So for this 90 degree, because minus tan inverse, so we will say minus 90 degree. So I will write here minus 90 degree. Now for this second term, I will write again, it is in the denominator, so I will take minus tan inverse of imaginary part by real part. So imaginary part is j omega, so I will write omega divided by 1. So simply we can take here omega. Then for the third part, minus tan inverse of imaginary by real, that is omega by 2. So this is getting completed. Now we will take the value of omega or range of omega. So for this section C1, omega varies from 0 to plus infinity. So I will take omega is equal to 0, omega is equal to plus infinity. Then what is the value of magnitude and what is the value of phase angle phi, that we have to calculate. Put omega is equal to 0 here. So phi divided by 0. So here 0 plus 1, 0 plus 4, that is under root of 1, under root of 4. But here this term is 0. So this whole denominator will become 0. So anything upon 0, that is equal to infinity. Now when we put omega is equal to infinity, then phi divided by infinity. So phi, and here infinity plus 1, that is equal to infinity. So these terms will also become infinity. So anything divided by infinity, that is equal to 0. Then we will move for the phase angle phi. Now put omega is equal to 0. So what is the value of tan inverse of 0? So tan inverse of 0, that is 0. Now if we observe tan inverse of 0, that is 0, minus tan inverse of 0 by 2. So 0 by 2, that is 0. So tan inverse of 0 is also 0. So what is the remaining angle? That is minus 90 degree. Now when we put omega is equal to infinity. So when we put omega is equal to infinity, so we know that tan inverse of infinity is plus 90. So here plus 90, but minus sign is already present. So I will write minus 90, and here is also minus tan inverse of infinity by 2, that is infinity. So minus 90. So what is the angle? That is minus 270 degrees. So these are the angles for the omega, 0 and infinity. Now how to plot this polar plot? Now omega varies from 0 to infinity. That means magnitude will start from infinity and end towards 0. Angle will start from minus 90 to minus 270. So for this S-plane, we have to first plot the angles. So here 0, minus 90, minus 180, minus 270. Because omega starts, so this is the start value. Here omega varies from, that is start point is 0, end point is infinity. So here omega ends. So this magnitude and phase angle is end at these points and these angles. So what is the start point? Start point is at infinity and angle is minus 90. So here this magnitude is infinity along this minus 90 degree. And this is the start point. And what is the end point? 0, minus 270. So 0 is here and minus 270 is along this line. So we have to join. So along this minus 90 here is infinity, and now we will join this. Now how to show arrow? From start to end. Now we will move for the step 2. Here mapping for section C2. So what we know about the section C2? That is theta varies from plus 90 to minus 90 degree angle, and we have to put S is equal to limit r tends to infinity r e raised to j theta. where r indicates magnitude and this e raised to z theta indicates us the phase angle. So in this given transfer function, if we put here s is equal to limit r tends to infinity r e raised to z theta, then how we can write this? That is phi divided by, I will put here r e raised to z theta, then in the second bracket r e raised to z theta plus 1, then again r e raised to z theta plus 2, bracket complete. Now how we can simplify this? So we will take here r e raised to z theta as a common term from these two brackets. So again we will move for the next step, phi. Now if I take as a common term, that is r e raised to z theta, r e raised to z theta. So if we multiply these three terms, that is this first r e raised to z theta is already present, then from these two brackets r e raised to z theta, that is 2 times. So if we multiply all these terms, then it will become r cube e raised to 3z theta. Now here if we take common, then in this bracket 1 plus 1 divided by r e raised to z theta, this bracket complete. Now in the second bracket 1 plus 2 divided by r e raised to z theta, this bracket is also getting completed. So this is the simplified form. Now we know that limit r tends to infinity. So when we put r equal to infinity, then how we can define this? So when we put r equal to infinity, that is phi divided by infinity. So here is also for every time if I put here infinity, then 1 divided by infinity. So 1 divided by infinity is 0. So 1 plus 0, that is 1, and here is also 1 plus 0, that is 1. But here because of r cube, here is infinity. So anything divided by infinity, that is equal to 0. So we can say that magnitude is equal to 0. But what about the angle? So if we solve this, here this magnitude becomes 0, but this angle e raised to 3z theta is in the denominator. So we will take this angle in the numerator. So how to take? So we will write here e raised to minus 3z theta. So this plus 3 will become minus when we shift this from denominator to numerator. So here this is the value. So this is for the magnitude, and here these two terms are separate. So I will write here for magnitude, I will take here only m. So this 0 is for magnitude and this is for phase angle phi. So these are the two terms. Now we know that this phase angle, or we can say theta, it varies from plus 90 to minus 90. So I will write here when theta is equal to plus 90. This is the start point, okay, and theta is equal to minus 90. So this is the end point. That is the start of section is at plus 90 and end of section C2 is at minus 90. So what is the start? So for this given transfer function, here is the answer. So when we put plus 90 instead of theta, then what is the answer? So here answer is, or we can say phase angle phi is e raised to 3 multiplied by 90, that is 270. So I will say minus 270. So e raised to minus 270 degree, and when theta is equal to minus 90. So minus 90 minus 3, that will become plus. So phi is equal to e raised to plus 270 degree. Magnitude is 0 and theta varies from minus 270 to plus 270. So how many circles are getting covered? So how to define? So for one circle total angle is 360 degree. So here it is starting from minus 270 and ends at 270. So I will take here 270 plus 270. So total angle covered is 540 divided by 360. So how many circles? That is 1.5 circle is getting covered. when this phase varies from minus 270 to plus 270. So this is the part of calculation, that is 270 plus 270 we have to take here is 540 divided by 360, because in 360 degree one circle is getting covered. Now one more rule is there that you have to note down in your notebook. In Nyquist plot, if phase varying from negative angle to positive angle. Now from this we can say that phase varies from negative, that is from minus 270 to plus 270, because this phase angle start at minus 270 and end at plus 270. So what is the direction of circle? So when this phase varies from negative to positive angle, then we have to draw anti-clockwise circle. Now how to draw? So here magnitude is 0. So I will take that is the value, that is magnitude nearby to 0, and I will draw here very small circle. So for this S plane I will take here the horizontal line as the real axis, vertical line as the imaginary axis. Now total circle covered is 1.5. Now this phase angle start at minus 270. So I will give here 0, minus 90, minus 180, minus 270. Now in the same way 0, plus 90, plus 180, plus 270. Here it is getting started from minus 270 and we have to show direction, that is the anti-clockwise circle. So anti-clockwise circle, that means in this direction. So very small circle, because magnitude is 0, it is starting from minus 270. Here one circle is getting completed. Now we have to draw the remaining half circle. This is the remaining half circle up to plus 270, and we have to show direction in anti-clockwise. So here the direction is anti-clockwise. So here is the form, that is in this way this circle will appear, or we can say in this way the section C2 will appear big, but here the magnitude is 0. So in final Nyquist plot we will not show this section C2. Now we move for the step 3, where we have to take the mapping for the section C3. So what we know about this section C3, where the frequency varies from minus infinity to 0, and this plot is known as the inverse polar plot, and we have to put S is equal to minus j omega. So what is the polar plot? So polar plot is here. This polar plot is starting from infinity and end towards this origin. Now inverse polar plot is mirror image for this polar plot. So we have to take this opposite step, that is inverse polar plot will start at origin and end towards the infinity. So I will draw here the mirror image, that is starting at origin and ends towards the infinity. So we have to show arrow in this direction. Now we will move for the step 4, where the mapping of section C4. So for this section C4, theta varies from minus 90 degree angle to plus 90 degree angle, and we have to put S is equal to limit r tends to 0 r e raised to j theta. So when we put this value of S in this transfer function, then phi divided by r e raised to j theta in the bracket r e raised to j theta plus 1 and r e raised to j theta plus 2. Now here r tends to 0. So here no need to simplify this, because simply if we put 0 here, then 0 multiplied by anything, that is 0. So if we observe how we can take this value. Now if we put r is equal to 0, then here this term will become 0. Then 0 plus 1, that is 1. 0 plus 2, that is 2. So 1 multiplied by 2, but here r is already present. So 1 multiplied by 2 multiplied by 0, that is 0. So anything divided by 0, that is infinity. So this infinity, because when we put the value of r is equal to 0, then this is the magnitude, that is I will say m. Now what about the angle e raised to j theta? So if we observe this r, when we put r is equal to 0, then here e raised to j theta, that is r 0 multiplied by e raised to j theta. So this whole term will become 0, this whole term will become 0. So only 1 e raised to j theta in the denominator is present. So if I take this denominator term in the numerator, then it will become e raised to minus j theta, and this is nothing but the phase angle phi. So this is the magnitude, this is the phase angle, and we know that theta varies from minus 90 to plus 90. So how we can define this phase angle phi? So if I put theta is equal to minus 90, then minus 90 minus 1, then this phase angle e raised to plus 90. When I put theta is equal to plus 90, so here plus 90 minus 1, that is e raised to minus 90. So this theta is minus 90, this is the start point, and here theta plus 90, this is the end point. So here phase angle plus 90 is the start point and phase angle phi ends at minus 90. So here phase angle starts at positive angle and ends at negative angle. Now what is the total angle covered? This 90 plus 90, that is 180 degree, and 180 degree, that means half circle that is getting covered. What is the magnitude? Magnitude is infinity. And here this is the important rule that we have to note down, that is in Nyquist plot, if phase varying from positive angle to negative angle, then we have to draw circle in clockwise direction. So this is important because phase angle varies from, that is start at positive, end at negative, and magnitude is infinity. So how to draw this plot? So this is the real axis, here is the imaginary axis. So if I take angle, here is 0, minus 90, minus 180. Here positive angle 0, plus 90, plus 180. Now magnitude we have to take infinity. Then we have to take phase angle start at plus 90, ends towards minus 90. Only half circle is getting covered because 90, 90, 180, and we have to show circle in the clockwise direction. So I will draw here. We have to show direction is clockwise. Angle plus 90 to minus 90. So this is the mapping for section C4. Now we will move for the step 5, that is the point of intersection of Nyquist plot with real axis. So for that we have to show imaginary part is equal to 0. So what is the first step for that? We have to take S is equal to j omega. So when we put S is equal to j omega, then phi divided by j omega in the bracket j omega plus 1, j omega plus 2. Now we have to multiply and divide with complex conjugate number for this imaginary part. So how to take the next step? That is here j omega plus 1, j omega plus 2. So here imaginary part is j omega. So for this j omega, we have to take the complex conjugate, that is I will take this j omega as it is. Now 1 plus j omega. So I will write here 1 plus j omega. So what is the complex conjugate? That is 1 minus j omega. Now for this 2 plus j omega, I will write 2 minus j omega. So these are the two brackets that are we have taken. So we have to take these brackets in the numerator also. 1 minus j omega, 2 minus j omega. Now what is the next step? So if we observe these two brackets, a plus b, a minus b. So a plus b, a minus b, that means a square minus b square. So I will write here phi 1 minus j omega 2 minus j omega divided by j omega. Now a square minus b square. A is 1, b is j omega. So a square, that is 1, minus b square, that is j square omega square. So what is the value of j square? So j is equal to under root of minus 1, j square is equal to minus 1. So 1 minus 1 into omega square, that is 1 plus omega square. Here also 2 square, that is 4, and here j square omega square, that is 4 minus omega square. So minus will become plus, 4 plus omega square. Now this j is in the denominator. So we have to cancel this. So how to cancel this? I will multiply and divide here with 1 by j. So if in the numerator and denominator I will take here 1 by j, 1 by j. Then this jj is getting cancelled from the denominator, and this 1 by j is nothing but, if I take this j in the numerator, then it will become minus j into 5 in the bracket 1 minus j omega, 2 minus j omega divided by 1 plus omega square, 4 plus omega square. Now I will multiply here this inside. So I will first multiply these two brackets. So how to multiply? This 1 multiplied by 2, that is 2. Then 1 multiplied by minus j omega, that is minus j omega minus 2j omega. So this total is minus 3j omega, and minus will become plus. So this minus will become plus j square omega square. So j square is minus 1. So again minus omega square term is there. So bracket complete. Outside the bracket we have to multiply with minus j phi divided by denominator as it is. So in the denominator all the real part is there. Now again with minus j phi I will multiply inside the bracket. So if I multiply inside the bracket minus j phi into 2, that is minus 10j, then minus j phi minus 3j omega. So phi multiplied by 3, that is 15. Here is 15. Then j is j square. This minus will become plus, but because of this j square again minus sign is there, and here omega. So minus 15 omega. Then again I will multiply this. This minus will become plus. So here 5j omega square. So plus 5j omega square divided by 1 plus omega square, 4 plus omega square. Now if we observe, here is the imaginary part. Now here this minus 15 omega is real part because no j term is there. So I will separate here real part and imaginary part. So minus 15 omega, this is the real part, and plus 5j omega square minus 10j, this is the imaginary part. So for this imaginary part, if I take j outside the bracket, then j inside the bracket 5 omega square plus minus 10. So minus 10, bracket complete. So this is the imaginary part. So how to solve this imaginary part? That we have to take j outside the bracket. Now if I take this j outside the bracket, then this whole part is the imaginary part, and we have to show imaginary part is equal to 0. So I will take this imaginary part, that is 5 omega square minus 10 is equal to 0. So 5 omega square is equal to 10. Omega square is equal to 2, and omega is equal to under root of 2. So value of frequency, that is omega, is equal to under root of 2. Now we have to take the magnitude. So how to take magnitude? That we have already written the formula for the magnitude of Gj omega, Hj omega, that is equal to phi divided by Now here for this j square omega square, so under root of j square, because here modulus is there, so this j square, that is negative value, is getting cancelled. So here is omega, then under root of j square omega square plus 1. So this j square we have to, if I take modulus, then it will become plus 1. So here only 1 plus omega square, and here under root of 4 plus omega square. So this was our magnitude. So we have already calculated this. Now if I put root 2 instead of omega, then how we can take here? So root 2 square, that is 2. So I will simplify this, 5 divided by root 2. Then here 2 plus 1, that is 3. So under root of 3. And here is also root 2 square. Omega is root 2. So here 2 plus 4. So under root of 6. So we have to solve this. So if I take under root of 2, that is equal to 1.4 multiplied by under root of 3, 2.4 multiplied by under root of 6, that is 6. So 5 divided by 6. So 5 divided by 6, that is 0.83. So this is the point of intersection of Nyquist plot with real axis. Now we will move for this step 6 to draw the Nyquist plot. For that we have to draw this one horizontal line, that is the real axis, and vertical line, that is the imaginary axis. Now on this we will plot some points. Now those points for to show the number of open loop poles. So S is equal to 0, S is equal to minus 1, and S is equal to minus 2. So here is 0, minus 1, minus 2. So these poles are shown with the help of this cross sign. Then there is the point of intersection of Nyquist plot with real axis. So it is 0.88. So this point is also shown. Now we have to draw first the plot for section C1. So for this section C1, we know that it is from this minus 90 degree angle, it is getting started, and magnitude, that is infinity. Then it is moving. Here the point of intersection is 0.88. So we have to show here 0.88, and it ends to the origin. So here we have to show it ends to the origin in this way. We have to show arrow also. So here minus 90, minus 180, minus 270. So we have to show angles also. So here is 0. So this is the plot for section C1. Now we will move for the section C2. So for this section C2, magnitude is 0. So for this section C2, we will not take any plot. Now for the section C3. So section C3 is nothing but the mirror image for this. So we have already drawn. Now we have to draw here, or we can say we will repeat here. Then we have to start this plot starting from this origin and end towards, or moving towards the infinity along this angle, that is minus 270. So this is the mirror image. So we have to show this point of intersection for this plot also. So we will show here. And we will show arrow towards the infinity. So this is for section C3. Now for section C4. So for section C4, magnitude is infinity, and we have to show the circle in the clockwise direction, that I have already shown. So I will show here with magnitude infinity. This is the circle in clockwise direction. So this is the Nyquist plot. So all these parts we have already drawn. So we have to just join here. Now we will move for the next step. So next step is to determine the stability. So how to determine? So for that, here one point is important, that is minus 1, 0. So this is the point minus 1, 0. Now first we will understand these terms. First term, that is n, number of encirclement of point minus 1 comma 0 in Nyquist plot. So what is this encirclement? So encirclement means what? Out of this Nyquist plot there are the circles, and if this minus 1 comma 0 point is getting enclosed by these circles, then this is known as the number of encirclement. Now in this diagram, minus 1 comma 0 is outside the two circles. So here is also one circle and this is the second circle, but it is outside the two circles. So we can say that for this plot, number of encirclements for the point in Nyquist plot is equal to 0. Then number of open loop poles, P means number of open loop poles in right hand side of S plane. So these are the number of open loop poles, but on the right hand side. So this is the right hand side and this is the left hand side for the S plane. So on the right hand side there is no any open loop pole. So we will say for this diagram it is 0. Then we have to calculate Z, that is the number of closed loop pole in right hand side of S plane. So to determine the stability, we have formula n is equal to P minus Z. So if I put 0, which is equal to 0 minus Z, therefore Z is also equal to 0. So number of closed loop poles in right hand side of this plane is equal to 0, and therefore we can say that system is stable. So from this we understand that whenever there is any pole that lies on the right hand side of S plane, then we can say that the system is unstable. Now one more important rule is there, that is here the number of encirclement of point, this is outside the Nyquist plot, so this number is 0, but if this point is getting enclosed by a circle, then this value of n depends on the direction of the circle. So for this encirclement, if this circle is in the clockwise direction, then we have to take value of n negative. Now reverse of that, if this circle is in the anti-clockwise direction and it is getting enclosed for this number, then we have to take value of n that is positive. So you have to note down this rule in the notebook.